So in this lesson, we're going to talk about quadratic functions, do a little review of the three different forms of quadratic functions. We have the transformation form, which is a times x minus h quantity squared plus k. And that specifically tells us right away that the values of h and k represent the vertex. And then we have standard form, which is the form we see quadratic functions most often. It's ax squared plus bx plus c. And then we have the x-intercept form, or transformation or factored form, a times x minus s times x minus t. And so we're going to look at transformation form first, and we're going to find the vertex, the x and y intercepts, and then we're going to sketch a graph. So first of all, when you're doing these, the first thing you probably are going to want to do is label the letters according to what you know. So for instance, in this case, we know that a is 2. We know the value of h is positive 3. Okay, remember, it's always the opposite. And the value of k is negative 4. So it's always a good idea to label the variables that you know. So here we have like a, h, and k. If we're in standard form, a, b, and c, or x-intercept, a, s, and t. So you might want to do that right away to begin with. So first we want to find the vertex. And the vertex in this case is just simply the point xh, or hk, so that would be 3 and negative 4. And the x-intercepts then, find those next. And the x-intercepts are represented by this these little formulas right here, which would be h plus the square root of negative k over a, and h minus. So we can actually do that in one step, and we can just say it's h plus or minus the square root of negative k over a. So that equals 3 plus or minus the square root of, here we have the opposite of k, which is negative 4, divided by 2. So our x-intercepts will be 3 plus or minus the square root of, and the opposite of negative 4 is 4, divided by 2 is 2. So when the square root of 2 is approximately 1.4, so this is approximately 4.4 when we add them and 0.6 when we subtract them. So when we look at the y-intercepts, or intercept, there can only be one y-intercept for any polynomial function. And to find this, we would do a times h squared and then add k to that. So we have 2 times 3 squared, and always remember that the rules for our order of operations, we're going to square the 3 first of all. So negative 3 squared is 9 times 2 is 18, and minus 4 would be 14. So then after we do that, we're going to graph this polynomial, this quadratic function. And so here I have a graph set up down here. Let me raise this up just a little bit. So we have, first of all, we have our vertex is at the point 3, negative 4, so that would be right here. And we have the y-intercept at 14, so that would go there. And remember that these are symmetrical, so if I went over 3 to here, I can go over 3 the other way to get a third point, so I can graph function. It doesn't like me here. Let's see if I can get it. Oops. There we go. And then to graph it, then I would just connect those points, and I actually have I put the function over here, so when I graph it, and it looks like this. And don't forget that when you're done, to make sure you put arrows on your lines to show that these do go on forever. Okay. So that would be the transformation form. Now let's go over and look at the next form, which is the polynomial or standard form. All right, and here we're going to do the same thing we did there. First of all, I'm going to label the values of a, which would be 1, b, which is the coefficient of x, that's 2, and c, which is 3 in this case. So to find the vertex, it says we have to do negative b over 2a, and then once I find that value, I'm going to plug it in here. back into the function to find the y value for the vertex, or the value of k. So first of all, we need to find negative b over 2a, and that'll give us the value of, actually it's the value of h if you want to think about it from the transformation form. So in this case, that's equal to negative 2 over 2 times 1, which is negative 1. Okay. Negative 2 over 2 is negative 1. So to find k then, the y value of the vertex, we will put negative 1 back in for x into our function. So negative 1 squared plus 2 times negative 1 plus 3, which that will be equal to, this is 1 minus 2 plus 3, which equals 2. So our vertex in this case would be the point negative 1, 2. Now to find the x-intercepts, you can actually do two different things. You can use the quadratic formula, which they've shown us here, or if you could factor it, you could use factoring and use the x-intercept form. But we're going to go ahead and use the quadratic formula here because it doesn't look like this is factorable. So to find the x-intercepts, we say x equals negative b over 2a plus or minus, and I like to write this as two separate parts instead of just one. So then we have b squared minus 4ac all over 2a. So this is actually turned out to be negative 1 here, because we already did negative b over 2a up here, plus or minus the square root of b squared, so b is 2 squared, there we go, minus 4 times a is 1 times c, which is 3, and divide that by 2 times 1. So that equals, let's see, 2 squared is 4, but we have 4 times 1 is 4 times 3 is 12. So 4 minus 12 is actually negative 8. So we have negative 1 plus or minus the square root of negative 8 divided by 2. So this ends up being negative 1 plus or minus. And here we're going to have a complex number with I. So we actually have, this is going to be 2I times the square root of 2. Oops, and that part right here is going to be over 2. Let me erase that. And then we can even simplify that further, so it's equal to negative 1 plus or minus I times the square root of 2. When I cancel out these 2's here. Okay? Which this means that it's complex, so it's not going to cross the x-axis anywhere. So there are no x-intercepts. Okay? And our y-intercept here is just going to be the value of 3. The value of c is the y-intercept. So we'll write that here. Y-intercept equals 3. Okay. So then we're going to graph this function also. So first of all, we'll mark our vertex on the graph, which is the point negative 1, positive 2. And then our y-intercept is 3. And we talked about symmetry, so over here we also have this point here. And then I have the function here, and I can go ahead and drop in that graph over here, and it's not drawing it for some reason. Let me try again. There we go. All right, so there's our graph. And once again, we want to make sure we put arrows on the end here that show that it goes up. Okay. And then we have one more form. We have the x-intercept, or factored form would be another way of saying that. Factored. And so to find the x, so we want to, once again, we want to label a, s, and t in this problem also. So in this case, a would be negative 1/2, and s is equal to positive 4, and t would be equal to negative 2. So this negative 1/2 here tells us that because a is negative, it tells us it's going to be reflected over the x-axis. It's basically going to frown instead of smile like the last two we looked at. So to find the vertex here, first of all, we're going to take and add the values of s and t together and divide by 2 for the x value. So the x value is going to be 4 plus negative 2 divided by 2. Right, so that is going to be equal to 4 minus 2 is 2 over 2 is 1. Right, so let's erase this and we'll call this h instead. So we're using that same terminology. So this is h is equal to this. And then to find k, we'll do the same thing we did with the standard form or polynomial form. And so we have negative 1/2. And then we're going to put 1 in for x. 1 minus 4 times 1 plus 2. So that's equal to negative 1/2 times negative 3 times positive 3. And the one thing that always happens is that these two numbers are always going to be the opposite of each other. Right? So this is equal to negative 3 times 3 is negative 9, and half of negative 9 would be positive 9/2, or if you like decimals, 4.5. So our vertex is the point 1, and then I like the fractional sum right is 9/2. Okay. And our x-intercepts then, let's change our pen here. Our x-intercepts are just the values of s and t, so that would be positive 4 and negative 2. Now to find our y-intercept, we have to use the formula that says ast. So we're just going to multiply them together. So we have negative 1/2 times 4 times negative 2. So that's negative 8 times negative 1/2 would be a positive 4 for the y-intercept. So then we're going to graph that also. So we are going to mark a couple points on here. We'll mark our vertex, which is the point 1 and 9/2, or 4.5. And we have a y-intercept of positive 4. So here, and then our symmetry puts us over here. And then we can just draw our graph. And then we would once again remember to put the arrows on the end. Okay, and that is about the 3 different forms of quadratic functions.